landing AI at the edge. Yang Wu is going to be presenting for us. They are the RT Thread AI CTO. He has over 20 years of experience in software development industry. So with that in mind, I am going to hand things over to you to share with us your knowledge on how we do AI at the edge.
Yeah, thank you. Let me share my screen. Okay. Okay. Hi, developers all around the world. I'm Yang Wu, and I lead the AI development team here in ArtThread. My team focuses on help developers in ArtThread community to put AI capability into edge device easier. Okay, why we think this point is so important that ArtThread need to build a team to create the solution to make things easier, because I believe IoT is just a natural next stage of our society improvement. We all know our society is keep informatization for many years since we invented the computer. I haven't worked in this industry since 1997. Yeah, and at that moment, we are using computer, PC, desktop, laptop, and so on. But they are improved very fast. We can take a little time to look back that the society improvement is focused on three aspects. If we observe those three aspects carefully, we can have a clear trend to show where we are going. First, it's the connected. How are things connected? Second is how we interact with this connected world, and availability of this connectivity and the accessibility to the information. So back to early days, computer was invented as a super powerful calculation tool. And soon we figured out that we can do business processing with this powerful machine. And soon it moved on to everyone's desktop. Indeed, Microsoft founder Bill Gates has his early vision for Microsoft is to put a computer to everyone's desktop. It has to be true very soon. At those days, computer is a hard to operate device. People need to take a course or be trained before they can take advantage of this device. And at the beginning, we use a keyboard to type in specific command characters and let the computer know what we want and let the program do the work. Later, we have mouse and GUI, so it's much easier, but you still need to learn and give the specific pointer to the interface to show what you want, and the computer will give you a response. Of course, we have to sit in front of that machine, right? So for those days, we call it information island because computers are not connected. If I need to move some data or information to another computer, for example, bring it from office to my home, or just share a file to the colleague just next to me, I will use a floppy and then hand it over, and he will copy the files to his computer. So every computer has its own operating system, storage, files, So that's why we call it information island. With more usage of the computer and more people relies on the computer and more interactive between these people. So we need to share information, and soon we invented a network which we use some wire to connect computers together, and we define protocols over the physical connective, and we have a network. At the beginning, it's just a small network. We call it a LAN, a local area network. Just a few computers in same room or so. But with more and more business work and personal tasks moved on to computer, we have to take care a lot of data to move here and there. So uh, more people join in to use the computer, and the more business, more part of people's life moved to computer, and it make the computer more attractive, more important. So soon it grow up to internet. Today we see uh, almost most of human activities are supported or collected by the internet. If you generate some data or you do something, you most likely will have some data footprint stored somewhere. And during this improvement, uh, the interactive method is improved as well. We use a better GUI. Later, we use touchscreen on cell phone, and the device can go with us. It's just in our pocket. Today, we can see the information of the whole world just on our fingertip. For example, the conference we are doing here is the best example. We no longer need to fly over the sea to get some place and gather around, though chat face to face and do some networking is very good. But it's not necessary. We do it because we believe it's better. If we have trouble because the situation now we have, we still can do anything we want. Here in China, I don't know where is my wallet for about 3 or 5 years, and I do not use cash. I use my phone for everything, and I can order dinner even at this moment. It's 2 a.m. here, and everything just works fine because the world is connected and the people are all in this world. I have a reference number. There are about 6 billion phones now in whole world, and over 60% of people are connected to internet. So this world is really huge, and is it enough? No, I don't think so. We want more because there are still a lot of things which is not smart enough to be connected, to talk to us, to respond our request. That's why the society move to IoT, Internet of Things. We can call today's internet is the internet of human. So we will move to internet of the things. Everything, the wall, the door, the light, the phone, the TV, air conditioning, car, anything, you name it, it will become a smart object and connected to some network. So with that, we can talk to them. We can literally talk to a device by voice and give it command and let it do something or change its state or send some data to somewhere. That is a new way to interact with the devices. We call it NUI, natural UI, because we just need not learn how to use it. When we talk to people, we use our native speaking language and use face use our finger, your hand, your body language, all kinds of these things we are accustomed for many years. So everyone can do that, need no training, need not take a course to use it. I have very impressive I was very impressed by iPhone. The first generation iPhone, I bought one, and my son is the same age as iPhone indeed. And when I see he is about 1.5 years old, and he can unlock that phone and to play it, though he don't know what it is really, but he can interact with it. That is very impressive. But it still need use the finger. You need try something, and then you will know. I can use my finger to do that. But if we can talk to my TV to say, play my favorite science fiction movie, and he will, the device will show a list of the movie, or I can tell the uh, air condition to lower the temperature for 1 degree. That would be very good, very handy. Today, we cannot do it because I need to find the remote controller or some controller wired with that device. But soon, we can do that. And we can do it everything, everywhere. It's very handy, but also brings some issues. Firstly, so many devices connected together interact with people to do all kinds of things. It will generate massive data. To take care of this data, process them, digest them, and get knowledge and take advantage, we need programs to run over the data. Usually, programs like us uh, write programs to figure out the pattern and make it wrong, right? But now we already know we need a special program which can figure those things out by itself. Then we can handle the massive data generated by internet. In future, uh, it will be worse. We will rely on AI to process them. And another part of issue is the challenge of security and privacy. You know, indeed, I have a interesting device at home. I can unlock my door by my fingerprint. Indeed, there are devices can use facial recognition and voice, all kinds of bionic features. But this device is interesting because it's offline. If the maker tell me that device will send your fingerprints over cloud and compare with some data stored over cloud, it's very precise. So the cloud has good enough computer power which can do very good algorithm to give you the result. It may be better than this door because it really has some trouble sometimes. If my finger is get a bit wet or something, or too dry or too wet, it cannot respond. I need to swipe on my clothes and try again. I believe to make more computer power to do the complex algorithm, it can do better, but I will not buy it because I don't believe they will not leak my data. Maybe they don't want, but one day, unfortunately, it definitely happens. So we need to take care of it. This must be done in the edge on that device by itself, not connected to something else. And uh, for the safety of my home, I do not want that door connected to internet, of course, because we all know uh, system is built by human, and the human makes errors. There must be some bug, and there is always some people smart enough to figure it out and take advantage of it. So that is quite interesting. And the worst part is fingerprints, facial recognitions. They take bionic features, and you cannot modify that. Once these features are leaked, then people can fake it, and you are banned forever from use this feature. That is terrible and scary. Okay, with all these important things and challenges, I think we can take a serious look at AI at the edge. So let's start with what is AI. Then I will take a quick glance at the challenge of doing AI at the edge and what we have done to make it easier. Firstly, let's make a consistent definition about what is AI. So later you will know what I'm really talking about. Let's make a solid discussion ground. Here I Here I show you a conversation to a chatbot. Do you think it is AI? Do you think this bot has some intelligence? Maybe, maybe not, right? No, it's not. It is just a string replacement program. Uh, just a few lines of Java code I already displayed on the screen. But how could it be uh, performed so well? If you feed the question sentence to this program carefully, and it will give you a good answer. Looks like it understands what you are asking. Yeah, because the replacement is simple, but what to replacement, how to replace those things are the knowledge, are the part of intelligence. It is the syntax. It's the knowledge about human make question sentence and get a confirm answer. So it shows when we can do something before we can do it, we believe it is part of human intelligence. But once we can make a machine or computer to do that, we don't think it's intelligence. We call it automation or machine or computer or program, but we don't call it AI. That's the interesting part. So when we talk about AI, what is really we are talking about? Indeed, AI is just a program function, just like we write every day. Let's see an ordinary program. We handcraft every line of code, make the whole program looks like a function. It takes care of input, generate output. If we just missed one point, there is a data we did not take care, then we have a bug. That's our life, right? And classic machine learning is a bit different. It separates the program as two parts. One part deals with the input data and convert its format to some data format easier to handle with. We call it feature extraction or feature converting. The knowledge and the effort to create this function, we call it feature engineering. And the feature engineering is hard. It requires you understand the domain very well. You need to be a language expert if you are doing a language feature extraction. You need to be image processing expert if you want to create an image feature extraction program. But once we have done the hard part, the later part is easier. We can use algorithm. This algorithm is a function, you can think so, but it has a lot of parameters inside. And we can use same algorithm with same set of parameters, but give different values to these parameters and make this algorithm mimic the function f we will write. For example, we can use a support vector machine to classify images. You are classify cat dog, it can do. Or you use another set of data to adjust the parameters like trees or flowers, it can do it well. So we see this program can learn, this algorithm can learn, and we use another algorithm to train this algorithm, which can learn some knowledge from the input data. That's statistics based. The math behind thing is maybe a little complex. Let's take a look from maybe 2000-meter high, and you will see it's just another function. But this function uses an algorithm which is very special. It can learn something, and by learning those things, it can change its behavior. And today, when we talk about AI, most likely we are talking about deep learning. Deep learning indeed is a part of machine learning. It uses neural network as the algorithm to learn something, but it's a bit step. It stepped a bit forward. Forward. Sorry. We no longer handcraft the feature part. We let the model and the training to figure it out by itself, so-called end-to-end training or end-to-end learning. We just use neuron or convolution or some structures, and like we use bricks in Lego to build a castle. We build a neural network model and use the data to adjust their parameter values. Then we use a training algorithm. The training algorithm indeed is quite simple. We get an input data, let the model calculate a result, and check the expected output of that input to see what's the difference, and use that difference to change those parameters. Just that simple. But this makes the AI, make a programmer to write a learning program way far easier. You no longer need to be expert of a specific domain. You just need some background knowledge. You should know, for example, convolution network is powerful for image network. LSTM is better for language. Today we will use something like transformer or something like uh, different new structures, which is powerful to handle different tasks. And you are done. You just get a lot of data and put them to a training program, and you will get a powerful model, a powerful program, which is super intelligence. That's interesting. So when we are talking about AI, it's just talking about a program which can learn by itself. It can learn things from data, change its behavior. That's we call AI. So we can make it clear, AI is just machine learning, and EAI, AI at the edge, or AI in embedded system, is use the machine learning algorithm in embedded system to make this device capable for sensing, processing, and make decision locally. Locally means just on that device. It is quite popular a few years ago to make a device connect to network, send the data back to cloud, and get a result. Is it AI? Yeah, it is. It's useful, but it's not what I am focusing. We are focusing make everything happen on that device by itself. And of course, for algorithm, we will focus on deep learning. So with these definitions, we can move forward to see calculation behind deep learning. As I mentioned, there are two parts of deep learning. First is inference, which is the green lines in left part. We have input, which named x, and some parameters, which are w and b. They will flow through that calculation graph or compute graph. Indeed, the whole left part is just one neuron. And you can clearly see they are multiply, add, just this kind of calculations. Most of neuron operations just multiply then add together. We call it multiple then accumulation. So MACC is for this operation. And we need use red line to change these parameters to optimize the neuron to make it adapt to our problem, indeed the data set. Okay, we are using a lot of neuron. Indeed, one neuron is quite limited. So here on the right part, you will see we use a matrix multiply to show the calculation. One neuron is one row matrix multiple one column matrix, and we get our result. If we have 10 neurons, then it will be a little bigger. If we follow that 10 neurons with another layer of 10 neurons, we will use the output of last layer to generate as input and multiply new parameters and get its result. The output of every layer, we call it activation. So when I mention activation, I just mean the output of a neuron. So matrix calculation is very important for deep learning. Fortunately, it has been researched for many years. The algorithm to optimize the calculation has been invented for many years, and we have hardware designs to make it happen fast. Because matrix calculation can vectorize and run parallel on the hardware, so it can be very fast. But if we just use a normal MCU or we call MPU or application processor AP to run this algorithm, it will be slow because our network is huge. Usually you will use thousands of neurons to make a useful network. That means huge amount of calculation. How can we make it possible on edge to run this kind of calculation? We need chip specific designed to accelerate the calculation. So there are people saying now we are at the age of no chip, no AI. There are so many vendors use different ideas. Most of them focus on make the calculation just mentioned faster by introduce the new instruction set into the processor or use a specific processor unit. Usually we call it NPU to accelerate the neural network. But there are people thinking differently, like make storage do the computing and neuromorphic computing, which is mimic the human brain structure in silicon, and it sounds promising indeed. There are so many chip vendor or hardware vendors, but only have a chip, it's hard to use. So every vendor with ambition will provide their own tool chain, the inference engine, because we most likely do inference on device. There are solutions to make training on device possible, but most likely we will do that on cloud and put the model generated to the edge and make it run. So most of edge AI are doing inference. To make these things done, every vendor will give you a tool chain and say how handy it is and make it run really fast on their own device. But since it's changing fast, today you use this chip and the next year there is a more powerful chip. If it's from same vendor, maybe they will keep some compatible ability that make it possible to reuse your assets. But if there is a new competitor provide a better chip, most likely you will choose it and you will switch. Then you need to learn a new whole set of tools like uh, converting the model and optimize it and put it on the device and call some API. Just start from beginning. And all your code you write before is useless. That is very, very worse. This is the major part of AI challenge. That means fragment, right? Uh, IoT is a fragmented world indeed, because the scenario is massive indeed. From a Bluetooth headset to a vehicle running ADAS, they are all edge AI. They are all IoT device, but they need a different connective, different power of calculation and come with different kind of battery or connected to something or just use battery. That means the whole things are different. If you focus a specific business area, maybe it's much more stable, but the whole IoT world is quite fragmented. When we put AI ability into the embedded system, what will new challenge beside the fragmented issue? There is a research, indeed there is a paper to collect questions from Stack Overflow to see what's the problem people are asking when they are trying to deploy AI model to a device. Most of these devices are just a cell phone. Because when the survey is doing, cell phone is the bleeding edge device. Today we have much more choice indeed. It shows there are a lot of numbers on screen. I will not read it one by one. I just want to tell you, it surprised me because most of questions is not related to the hard part, that is algorithm, math, or just optimize the things to get a reasonable performance. That is rare part. Most of people just blocked by compile a library or convert a model and make things just start up. That surprised me really. So what we can do to avoid the developers in artist-led world to have these troubles? Then we provided AI packages. ArtistRed has a packaging mechanism. There is a website. You can use the link on the screen to find all kinds of packages. Of course, we have a catalog for AI packages. You can find TensorFlow Lite Micro, You can find CMSIS includes CMSIS NN and some others. With these packages, you can just use manual config or ArtPie Studio to enable this library just by a few clicks or just a few key press. Then it will get compiled smoothly. But you still need to write, you still need to learn different API and write a program and even to re-implement the model, just use the API of the library, which is a lot of work and hard to start still. So how can we make it even easier? I have think it over and talked to people working in this industry, and I get some idea. When we develop a product with AI capability for Edge, we have this workflow. We should define a problem firstly, which means figure out the scenario and choose the uh, description of the data and ensure the possibility to use AI to solve the problem and define metrics. That is the defined problem. Most likely, people has a lot of talent to do this part, and then we need to create a model, a deep learning model. Usually, people will check state-of-art model firstly. If there is one, we will check, we will evaluate it and ensure it is powerful enough to solve our problem or not. If not, we will do some model research, define a structure, collect a data set, and train a lot of models to compare them, choose the best one, and move on. So this part is some kind of mature enough now. There are so many talent focused on this part. So the problem is the model deployment. This part is quite difficult so far because our device usually has quite a limit computer power, quite a limit memory and storage. So we cannot just pull a best model, the SOTA one, to put them on our board. For example, VGG16, I remember it is about 5 megabytes, just the model file itself. The whole board cannot contain that model. How can we use it? So we need to do a lot of optimization, usually called quantization, prune the structure, and distill the knowledge to find a small model with a little loss. Usually they are loss, and choose the best affordable hardware and make this model to run. We just find a balance point for the bigger model and limited or just the cost constraint of the device. And we need to convert the model we can use to proper format and the right program to load it, make it run on the device. And then we tune that device. We tune the AI program on that device, make it its functionally prop and get better performance. This part is quite a struggle. We need to focus on this part. Later are just our business, right? Uh, People in IoT development industry are genius enough to handle this part. The different part may be the post-processing of AI model that is a little challenge for people without AI background. For example, facial recognition, object detection model will generate a lot of boxes. Then we need to use NMS to choose the best one to get our result. what is what is NMS? You need to understand it and implement that. That is a little struggle, but not that hard. And of course, we need to monitor our model running on the device, especially when we put it to market, deploy it to our customer. And we still need to watch the device to get idea how it really work. And if we can have the possible to collect samples, especially those samples does not handled by the model very well yet. If we can have the permission to collect the data, we can improve our model quickly. We need to worry about that. Sorry, I forgot that. Okay. So this is the whole workflow, and the most difficult part is the model deployment. If we can create a tool to solve this problem, it should be looks like this. We can step further from AI library to provide a toolkit, which provide one command which run on our computer. When I have a model trained by my favorite framework in my favorite file format, this command can convert it and put it into an artist-thread project. Even better part is it not only puts the model properly into the artist-thread project, it runs fast on that target device. It runs on best performance on that target. That will make things just perfect. With this idea, we create ArtistThread AIKit. With ArtistThread AIKit, the development of AI at the edge looks like this. Firstly, we need to get an AI model. You have a lot of choice at this step. You can train it by yourself. Most likely, we will do it this way. But you can also use a SOTA one or open source one, which is pre-trained or have a program you need to retrain it. But anyway, it is existed. You just choose one. And of course, we can buy one. There are many people are glad to sell you some models because it's quite challenging for AI algorithm research company to make money now. So we have a lot of choice, and it is not too hard to get an AI model which working. Then we need an ArtistThread project. It means put ArtistThread OS kernel and the BSP together for the target development board or target platform. These two steps are just a preparation for the development of EAI. The really working part just begin here. The step 3, we will run the command from ArtAI kit. We call it ArtAI tool. It is a Python script indeed. Then it can generate proper code, put files like inference engine or all kinds of things into that BSP project. Next, we will write a few glue code using the API provided by RTAK library for the runtime. It's very thin library, so it is just a direct wrapper for underlying things, but it provides a consistent layer. Just like we provide HAL for the hardware. So it's just about 4 or 5 lines of code to glue the RTI library. And we call that find the model, call the model, get a result, just like that. Then we can compile a project, burn it to our device, run it, see if the result is good enough. If it is not, usually we have two kinds of workflow. One is the right part, which means we are evaluation we are doing evaluation for different boards. For example, I have 4 vendors which all provide evaluation board to me. But which one is best for me? I have a model chosen. Which one can run the best, fast or low latency or this kind of things. Without ArtPie AIKit, we will create 4 projects and do 4 times of programming, just implement same thing. That is really annoying. If all these 4 platforms already supported by ArtPie AIKit, then things are very simple. Firstly, we still need 4 BSP projects. Usually, the vendor will provide it, and then we just use that command, the step 3. We prepare a new BSP project and run ArtPie AIKit command again, put the model into that project. And this time we do not write the code again. We can just copy the glue code from existing project and done. We can just compile, burn, run, evaluation. Just that easy. Another scenario is different. We do not have the choice of the hardware. We already choose that. Then decision is done. We just need to find a best model for that device. That is still same easier. We just go back to step 3. Find a new model and run the command again. Put that model into this ArtPie BSP project and burn, run, evaluation, see the result. If it's better to compare to the last one, we will choose this one. Just that easy. You don't need to write the glue code or even don't need to copy it again. It sounds like quite neat, right? Is it real? Yeah, we have done that. I will show you. Let's open a command window inside the AIKit and run the command. What do you see? Indeed, we have a lot of examples, not just this one. Here are a few of them. Left part is the examples running on the ArtPie. ArtPie is a development board for developers created by ArtPie. Now we sell it on Taobao. People are still finding a way to make it available overseas, but it's still working on. Soon, I think you can buy it in other ways. The interesting part is there are 1, 2, 3, 4, 5, 5 examples running on ArtPie on the screen. Those examples are not created by ArtPie team, not by us. Who created them? In July, we hold a summer camp in Nanjing, and we collect 22 teams students from some colleges, indeed from different colleges. Each team have three students. We train them for 3 days from beginning. What is AI and how to use TensorFlow to train a model. Start here, and eventually deploy it use AIKit. Then we give them 2 days to create these examples. They find the idea by themselves. It's 2 days hackathon. And I didn't expect everyone can finish their idea indeed, but they surprised me. They work hard and all have get things done. The last day, everyone had the chance to pitch their ideas. So the really interesting part here is even a student can use ArtPie AIKit to get hands on AI on the edge just by learning it in 2 or 3 days. I think that is simple enough. The right part is a bit complex. Those examples are created by us. And you can see with a little more calculation power, the computer power, it can run face landmark detection, license plate recognition, or handmark detection. How powerful is this conjoint 210? It is indeed just one tech OPS. Yeah, one tops. Sorry, one tops. How strong is ArtPie? ArtPie is just come with MCU Cortex M7. Yeah, Cortex M7 running at 480 megahertz. It's quite a small device indeed. It is powerful for MCU, but it's really a low-end device for AI. But it's still capable of run a lot of things. Most of these examples are already open sourced at GitHub, especially those examples for ArtPie. You can search on GitHub and take a look. Okay. With the idea, what is ArtPie AIKit and how capable it is. Now let's look some technical details. Here is the architecture of ArtPie AIKit. I call it open architecture because it looks a bit complex on the screen, right? But the really interesting part, just the ArtPie AIKit tools and the ArtPie AIKit core library, just that too. They provide the user interface for program. The tools provides command and parameters as user interface. The core library provides APIs as user interface. The APIs, we separate them to inference API, IO pipe API, and the inspection API. Most important is the inference API because you use it to run the AI model. And the IO pipe API is powered by ArtPie device model, which make IO accessing. AI model needs some data input and get some result to output, right? It depends on some device. Fortunately, ArtPie has a consistent device model. We can take advantage of that. And ArtPie AIKit can run on different platforms and take advantage of the original manufacturer's optimization. They are powerful tools, they are powerful optimized runtime. We can use that. Of course, we can also replace them by our own. How can we use a structure to support that? we use plugin structure. Artificial AIKit tool has platform tools plugin, and the core library has library plugin. Tools plugin is for the converting time or development time, and the library plugin is for the runtime on the device. Then we can accumulate the progress of the industry by using a new plugin or update a plugin to take advantage of everything. This is already released on the ArtThread official repository. You can have a look. And just before this conference, we have translated most of the documents into English. So because it is a bit harsh here, so please file issues if you find the document is not so good. If you can PR something, that would be even better. Thank you. With this Artistrat AI Kit, we wish to build an open community together. There are people doing product development. They understand the application scenario very well. They are expert of the user, the end user. They know what they need and know how to make them happier, which is most important part of this industry, because we need sell something to make all of investment on the higher steps of the chain to get the money. But usually product developers are not expert of the AI model, and they rely on hardwares, and they use a lot of tools and service to get their things done. So I'm thinking about to set up a platform based on Artistrat AI Kit to pull everyone together, not only serve the product developers, but also bring the AI model researchers in, because they are AI experts. They have that expertise. They understand the problem domains very well. It generates very good models. If we need a customized version of that model, they can do that. So they can help the edge AI better. And of course, we need to bring the hardware manufacturers on this platform. They are experts of their architecture and their SoC, their accelerated processor, and they also provide optimized tool chain for their platform. Which they can sell this hardwares or tool chains for the whole ecosystem. The whole ecosystem can benefit from their expertise. And also we can involve the AI tools makers and service providers. They can provide the tools, all kinds of frameworks, and data as a product, or data set creating as a service, and all kinds of service we need. We can put it together. Eventually, I think we will have a market, which can be a website or just a page inside the Artistrat Studio. We plan to work it. We plan to create it in next version, so everyone can publish their capability, like a model or a hardware or a service. Then product developers can contact them or just place a purchase order, and we can make the developers in the whole ecosystem easier to find each other, work together to create a great product and make the IoT edge AI world become true. So here I invite you together to port the new models to this ecosystem, create demos, write articles, or just create a product to prove it is useful. If you really do that, please do tell us. I'm glad to add your name or icon to our repository. And we need success cases. Please do contact us if you working on a product. And we wish everyone who have the capability to add the plugin for new platforms or create a new plugin to integrate other tools and service, we can all work together to make it great and useful.